Our sun is a mighty force. It's a giant ball of burning gas, a star that holds our solar system together. The sun's gravity is what keeps everything in place, from the largest planets to the tiniest specks of dust. The sun is incredibly massive. Imagine over 333,000 Earths squashed together. That's how much matter the sun contains. This massive amount of matter gives the sun an extremely strong gravitational pull. It's like an invisible rope tugging on everything in the solar system. Think of gravity as a force of attraction. The sun, with its massive size, exerts a strong pull on everything around it. The closer an object is to the sun, the stronger the gravitational pull it experiences. This pull is what keeps all the planets in orbit around the sun. Now you might wonder, why don't the planets just fall straight into the sun? After all, gravity pulls things towards each other, right? Well, the answer lies in the planet's movement. Imagine you have a ball on a string. If you swing it around, the string keeps the ball from flying off in a straight line. Instead, the ball moves in a circle. The planets are like that ball, and the sun's gravity is like the string. The planets are constantly moving, traveling through space at incredible speeds. The sun's gravity acts like a giant, invisible hand pulling the planets inward. This interplay between the planet's forward motion and the sun's gravitational pull creates what we call an orbit. An orbit is a curved path that an object in space takes around another object. Think of it as a delicate balance. The planets want to keep moving in a straight line, but the sun's gravity keeps pulling them towards itself. The result is a continuous elliptical path around the sun. The shape and size of a planet's orbit depend on its speed and distance from the sun. Planets closer to the sun experience a stronger gravitational pull and therefore have to travel faster to stay in orbit. The sun's gravity doesn't just affect the planets, its influence extends far beyond, reaching out to smaller objects like moons, asteroids, and comets. These objects are also bound by the sun's gravitational pull, shaping their movements and destinies. Moons, for example, are natural satellites that orbit planets, but they are also influenced by the sun's gravity. This complex interplay of gravitational forces determines their intricate dance around their host planets. Section 5. Moons, held by a double grasp. Imagine a moon orbiting a planet. The planet's gravity keeps the moon in check, much like the sun holds the planet in its orbit. However, the sun's gravity also tugs at the moon. This creates a delicate balance. The moon is constantly being pulled by both the planet and the sun. This intricate gravitational dance is what keeps the moon in a stable orbit around its planet. The strength of the sun's pull on a moon depends on its distance from the sun and the planet it orbits. Some moons, particularly those farther away from their host planets, experience a more noticeable influence from the sun's gravity. Section 6. Cosmic wanderers. The sun's pull on comets and asteroids. Comets and asteroids, often called cosmic wanderers, also feel the sun's gravitational pull. These rocky and icy bodies travel through space in elongated orbits, sometimes coming close to the sun and then swinging far out into the depths of the solar system. The sun's gravity dictates the paths of these objects, influencing their speed and trajectory as they venture through space. Comets in particular experience dramatic changes due to the sun's heat and gravity. Section 7. The heliosphere, the sun's protective bubble. The sun's gravitational influence extends far beyond the orbits of the planets and the paths of comets and asteroids. It creates a vast bubble-like region called the heliosphere. Think of the heliosphere as the sun's protective shield. It's a region where the sun's magnetic field and the solar wind, a constant stream of charged particles from the sun, dominate the space environment. This protective bubble helps to shield our solar system from harmful interstellar radiation, acting as a buffer against the harsh conditions of interstellar space. Section 8. A universe without the sun, chaos and darkness. Imagine for a moment that the sun suddenly vanished. What would happen to our solar system? The answer is nothing short of catastrophic. Without the sun's gravity, the planets would no longer be held in their orbits. They would fly off in straight lines like a stone released from a slingshot, no longer bound to the system's center. The solar system would descend into chaos. Planets could collide, moons would be flung into space, and the delicate balance that sustains life on Earth would be irrevocably broken. Section 9. The Sun, our anchor in the vastness of space. The sun, with its immense gravity, is the glue that holds our solar system together. It dictates the movements of planets, moons, asteroids, and comets, shaping their destinies and influencing their very existence. From the smallest particles to the largest celestial bodies, everything in our solar system is bound to the sun's powerful grip. It is the anchor that keeps us from drifting into the vastness of space. The sun's gravity is a testament to the incredible forces that govern our universe. It is a constant reminder of our place within the cosmos and the delicate balance that sustains life as we know it.